Ladies and gentlemen, dear visitors on our video center, LMT Tools welcomes you to the web seminar Tapping and Tapping Chucks. My name is Martin Danielczyk. In the name of the LMT Group Academy, I welcome you here live at our Innovation and Training Center in Schwarzenbeck in Germany. To my right, I welcome Stefan Möller, our team manager, Product and Process Engineering here in Schwarzenbeck. Hello, Stefan.
Hello, Martin.
And Clemens Mohr, our chief technician here from the Innovation and Training Center and the Demo Center in Schwarzenbeck.
Hello.
Yes, what's our topic today? Tapping and tapping chucks. What will you show to you today in our live web seminar? Generally, we will talk about typical requirements for threading in cast iron, and then we will present you our world first modular thread tapping system, Exchange. We will show the tool, like in all our web seminars, in action on the machine, and afterwards we will explain you something about synchro chucks, why we need it and why we need it for threading and tapping. Clemens, I would like to ask you to prepare the show later on for the demonstration on the machine.
Okay.
And Stefan, we together should have a closer look on cast iron machining. What's particular in cast iron?
Yeah, there are indeed some typical requirements for threading when it comes to the material cast iron. Just to name the most remarkable, particular properties of cast iron are, for example, the brittleness. Cast iron is very well known for being very brittle, and this increases the risk of edge chipping. Also, sometimes you discover graphite enclosures and cavities, which also could damage your cutting edge. In materials like Triple G60, you will find we have a very high abrasiveness. Overall, we can say cast iron is a short chipping material. But what does this mean for our cutting tool? We need to have a very high wear-resistant cutting edge. It needs to be a hard cutting edge. But also, we need the high toughness for or against torque and bending stress. And last but not least, we need open flutes, spacious flute space and in combination with internal coolant for a very good, excellent chip evacuation, Martin.
Yeah, so now we have the requirements regarding the tool from the material side, cast iron we are talking about. But before we start deeper into threading, thread making in cast iron, what types of thread making tools do we have in our program at LMT in general?
LMT has a lot of tools to offer for thread making in general. Talking about cut tapping and thread forming, internal thread forming, which are very popular systems of making threads these days. We also have a wide range of thread milling cutters, which applies in larger threads. Going to the thread rolling tools. Thread rolling is a code forming process, a chipless process for external profiles and threads. And last but not least, talking about operations, thread turning, of course, should not be missed. Regarding the tool types, we have tools made from HSS, respectively HSS EPM, solid carbide, but also modular systems, which are becoming more and more important. Tools with indexable inserts, and for special applications, also tools with a PCD cutting edge.
Yeah. But PCD, I think, talking about cast iron today is not the issue. All those tools and all those applications, of course, you can find them in our catalog. You just see the sample of the catalog or the front page of the catalog, also on the presentation slide. Later on, you will get the internet address for our homepage. Yes. Thread making in cast iron is the topic today. So we will focus on cut tapping. So this is the process and the operation we focus on, but not on conventional solid HSS or solid carbide tools. Stefan, you will present us the world's first modular system for serious threading, serious production, thread making.
Yes. It's a great pleasure for me to introduce to you the Exchange. It's representing the best of two worlds, we call it, because it's the first modular carbide tap. That means we have a combination of the best of two worlds, from HSS world and also from the solid carbide taps. In detail, this means we have a solid carbide head with a Polaris coating. Polaris coating is a new developed coating, blue color coating, especially for cast iron machining with a special preparation for very good chip evacuation. We have a steel shank, which is giving very tough and flexible against torsion and bending. The range we offer so far is M8 to M18 in metric and also metric fine pitches. The chamfer forms available are chamfer form C and also form E, and very important, a very good variety of internal coolant solutions.
Yeah, so with Exchange we are covering the widest range of applications you may have in cast iron threading. So for our customers, this means it's time to change.
Absolutely, it's really time to change. That's a really good motto, because we have the best economical solution for serial production with the Exchange. We have Exchange is very cost effective. We have very high process reliability, especially if you compare this to a solid carbide tool. We have a high productivity, and we are saving resources because we are just using a solid carbide nib instead of a solid carbide tool, and all items are available on stock.
Yeah, that's already convincing, but before you convince us directly with the properties of the tool at the machine, one question. You're talking about cast iron, we are talking about cast iron materials. Is cast iron the only material and metal we can use the Exchange?
No, not really. So far, the Exchange is designed especially for short shipping materials. It's a straight flute version, so the target is the short shipping materials. Of course, the majority of short shipping materials belong to the family of cast iron machines, like gray cast iron, GG25, or even nodular cast iron, triple G60 as an example. But also short shipping aluminum alloys with a high silicon content, or short shipping copper alloys and short shipping plastic materials are possible to be machined with our modular tab Exchange.
Yeah, so short shipping materials. What I know about short shipping materials, what's very, very important is to evacuate the chips, because they are very small, maybe compact, and so you always need internal coolant. How is Exchange solving this problem or this requirement?
That is indeed very, very important to have internal coolant supply, and we have a very smart and very innovative cooling solution. It comes all through the shank, we say, because we know two different types of holes, of course, as you know. We have a through hole, which is requesting a radial type insert, means the coolant flow coming, leaving the shank in the grooves in the radial position, very close to the nib itself. And we have a blind hole situation where we need an internal coolant solution in axial direction. That means it goes through the shank, and also in this case through the screw, and go to your workpiece. So we have one nib, we have two different configurations of the screw and two different shanks.
Yeah, so looks very simple, looks very easy. You promised us a really cost-effective and performance system. So, Stefan, I would like you to join Clemens over at the machine, and that you both show us how easy Exchange is to handle, and yes, what's the performance?
Hi, Clemens.
Hi.
We were talking about the Exchange, and now we should know a little more about the assembly of the Exchange. What kind of recommendation you can give us? How does it work in general?
It's working very easy to set up. I will explain. You have in our Exchange system 3 parts. We have the steel shank, which has a very good torque resistant. We have the carbide head for high tool life and high cutting data. And we have the screw for a safe fixing of both. For the first, please check if the size of the carbide head and the size of the shank is the same. Please check after this if everything is okay with the tooth system, clean the tooth system, and insert the screw into the carbide head. Then you have to pre-adjust the head. Please give attention, very important, to have the flute of the inserts and the flute of the shank must be in line. After this, you can fix it with a torque screwdriver. I will show you here. In this area here, we have the torque screwdriver, and you turn till you hear the click. Okay, and now it's fixed. It's like a solid carbide tool.
Yes, thank you, Clemens. You told us that it's important to have the right torque when fixing the screw. How do our customers know which torque is correct for their exchange?
Oh, it's also very easy because every shank is marked with the right torque you have to put in your screwdriver. But it's the most easy possibility is to buy this torque screwdriver by the LMT because here it's preset, and so you have the exactly torque for this exchange. The screwdriver comes with the right torque, and then it's an easy way to make no mistakes for this one.
That's really very easy. So since now the exchange is ready for usage, Clemens, what did you prepare to show us how much value the exchange can add to our customers' production?
Yes, we will make a test, a demonstration. We will compare a standard HSS tap, it's a type G, with the exchange tool. This tool here, they have both the same diameter, and they will make a race. My colleague Martin Hahn, hello Martin, he prepared the machine with a plate with 100 core holes, and there we will compare both tools, and we have the HSS tool we recorded before, and you can see it in the screen below on the right, and below on the left you can see the live video outside from the machine. There you see the exchange in operation. This tool will be running then with internal coolant. When we start the video, we also start at the same time the machine. Now I have to ask the camera team, is everything ready? Ready. Okay. Martin, also my question, is the machine ready for the test? Yes. Okay. So, let's start the race. Okay, and you see during the first threads we are doing now, the cutting speed of the HSS tool is around about 20 meters per minute. And we need around 5 seconds for producing one thread. Much faster, because we have here much higher cutting data, is running the exchange. We have here the cutting data of 50 meters per minute, and we're making through holes M10 with a depth of cut of 20 millimeters. We use the exchange with internal coolant with the type radial because we have here through holes. We will tapping in the next minutes 100 threads, and a typical workpiece for such high numbers of threads is also a housing of a gearbox, Stefan.
Yes, that's right. This is a gearbox housing GG25 from one of our customers, but exchange in general is a very economic solution for a high volume serial production. Where do we find such parts? Such parts are usually found in automotive industries and their sub-suppliers. We talk about gearbox housing like we have here, we talk about engine blocks, of course, we talk about brake parts. And also in general machining you find serial parts or parts which are produced in mid-size and large serial ranges in like pump housings or frames. We said this already before, but it's very, very interesting, or we have to go back to this point once more. Exchange is combining the best of two worlds. We are combining the advantages and the performance of HSS, respectively solid carbide tool, in only one tool. Today we can say that all the tools available in the market, whether it's high-speed steel or solid carbide, they have advantages. But only Exchange is combining them all. We have fast operating times, we are very reliable in the process, and we have outstanding tool life. So Exchange has it all. This has been proven already in our customers' application, and I want to give you some good example. This is this part, the gearbox housing made of GG25. The customer has to do 50,000 pieces, and it's running a high-speed steel tab with a cutting speed of 30 meters, round about 1,200 RPM. That is already a very high cutting speed for a HSS tab. He was achieving a tool life of 5,000 threads, and the processing time per thread was 1.69 seconds. Then we bring in the Exchange to our customer and running it in a safe, stable process with 60 meters per minute. That means 2,400 RPM roundabout. That is bringing down the machining time per thread to 0.8 seconds. And by the way, we are achieving a tool life of an average of 16,000 pieces. So overall, that means, considering a lot size of 50,000 gearboxes, there's a cost reduction of almost unbelievable 53%, Clemens.
Yeah, and I see we are near by the end of the race. I think roundabout the Exchange has crossed now the 90 holes, and we will see what happened with the HSS tool. And you can see it now. The Exchange, of course, running much faster, and also we have a perfect internal coolant with this system here. And we have now one of the last threads to do. It's number 100. We're doing now. We stop now the video. Ready. And we have now the result. Our tool reached 100 threads in this round about 4 minutes. The other tool reached the tool thread number of 53. So what does it mean for your machining parts, for your production? Here you see what is the result. In the first 5 lines you see the results, what the HSS tool can do. Here you have the tool. We do first the first 5 lines. And if the camera goes up, you see around about 50 more threads we can do also with the Exchange. So we double the numbers of threads, and we go down of 50% of the machining time. And you know machining time is very dear, and so we earn a lot of money.
That's right. There's a lot of value added to your customer's production by getting almost 100% more output. So let me summarize the advantages of Exchange. As we have proven, it's really reducing cycle times, and that is a very important factor. It is very safe in process due to this modular system with a steel shank and a carbide tip. We are saving resources by just using a carbide nib. And we have fantastic tool life, increased tool life. So overall, we can really say we have maybe the most economic solution. Martin, that's it from us on the machine side for the moment regarding Exchange. Back to you.
Thank you, Clemens. Thank you, Stefan and Martin Hahn, for this very obvious demonstration of the performance of Exchange. And I would just like to point out, and it's really the world's first modular system that's reliable enough for a high-volume serial production. So really something outstanding and new. But what is important, if you want to have such a performant process, very often the total system, so that means machine plus tool holder plus tool, is not able to really get to the maximum output and to the maximum performance your tool can bring. And so we would like to present you our SCK Synchro Chuck program from our alliance partner Builds, because only with a good Synchro Chuck you will be able to get the maximum output out of a tool like the Exchanges. So Synchro Chucks in general, where can you use Synchro Chucks? Synchro Chucks are suitable for any kind of thread cutting or thread forming operation. And very important, they are made for machining on machines with synchronized feed. So the so-called rigid tapping process. It's mostly dedicated, and the biggest advantage you can take out of mid to high volume series production like you have with Exchange. And so here also we are talking about automotive components like engine blocks, gearboxes, axle parts, but also hydraulic or pneumatic serial components produced in a very high volume with high quantities and serial production. But now I would like again to ask our experts, Stefan and Clemens, why do we use synchro chucks and what's the real technical advantage? Why do we have to use it?
It's maybe not a surprise for you, Martin, but we have an answer to these questions. We have prepared an animation video, which may be now being started. And Clemens, please explain us in a few words what happened in a synchro chuck.
Yes. Here at the video, you see the difference between a shrink holder and a synchro chuck. You see, during this chipping process, we have with the synchro chuck less axial force, and you see a big difference at the reverse point. So there at the shrink holder, the force goes very high, and the problem is, you see, if the machine goes down with the RPM and with the feed rate and goes up, the second time if you reverse, there's a little bit different every time between the feed rate and the RPM, and then you have an actual movement of the machine in relation to the pitch, and then you have axial force. This force means for the tool, it's you have more wear at the tool, and you will see that you have not so good tool life in relation to the synchro chuck, and the thread itself, it's not so good in the quality.
Yes, and what's so special on Bill's synchro chucks? Bill's synchro chucks SCK is 100% sealed and leakage free. Also an MQL, working with MQL means minimum quantity lubrication. That is important because you need to have immediate aerosol flow working MQL from the very beginning. Then we can offer a length adjustment, which is possible from both sides. We have a suitability for running these SCK synchro chuck from builds up to 15,000 RPM. And very unique is that we have a suspended length adjustment screw. That means we have no damage on the screw, respectively on the tool itself. And that means it's totally maintenance free, very easy. The next chart we see in an MQL version means for optimized aerosol flow. As I said, it's 100% leakage proof, and we have MQL onto the cutting edge from the very beginning. Clemens, what is important in general when mounting, when assembling and builds SCK synchro chuck?
Yeah, there are a few points that it's important, for example, to put the disc in the right position in the clamping nut. You see, at the disc we have a marking area here, and this marking area should be gone inside of the clamping nut. So if you put it in and you press, you hear a click, and then it's the right position. Outside is no marking area, it's inside, and it's a good surface here. You see the flat is exactly straight, and then you put also at next the collets inside. But first let me explain a little bit about the length adjustment we told before, and this is also very easy to do by builds, and you can do it from the collet side to adjust the length, and also it's possible to adjust it from the location side. For this one, if you want to put in the tool, it's also very easy. You have here the clamping net, and you will put in the collet inside. After this one, you put the complete part on the synchro chuck, put in the exchange, and now it's clamping exactly with a very good run out, because we have a very high quality inside, and it's also the torque is very good, because we have there exactly fixed this one here for a best tool life and a best run out.
Okay, we have one more animated video for you to show you the suspended length adjustment screw. You see here in yellow, the tool comes in, the tab comes in, going to the adjustment screw itself, and in this case, from the location side, there will be the length adjustment, as you can see here. And after the right length has been set, the collet nut will be tightened. And during this tighten, there is an actual pressure build-up, which is now suspended here by an elastomer, and therefore no damage on the screw, no damage on the tab, and maintenance-free performance is possible. So the length compensation by an elastomer guarantees the maintenance-free performance of the built SCK chuck.
Yeah, and we have also a special safety aspect here, because if someone let the tool holder run with high spindle speed, the covered retraining ring avoid opening. So it's also very important.
Absolutely, absolutely. So definitely we can say that the SCK built synchro chuck is really adding value to your customer's production, to our customers' production in general. We have proven, or we can say we have increased tool life of at least 30%, in many cases up to 100% and even more. Due to these suspended unique clamping system, we have no damage of tab and adjustment screw, and therefore it's very easy to handle, and it's really maintenance-free. Martin, that's it from us and the machine for the moment, talking about the synchro chucks. Back to you.
Yeah, thank you, Guy, for leading us through the world of synchro chucks and explaining a little. For me personally, and I hope for you as well, it's been really very, very important and interesting to see why we are really using a synchro chuck and what's really the point that makes tool life longer using a synchro chuck. And this also explains why you need synchro chucks, machining with high-performance tools like with the Exchange we presented to you before, because getting the best out of two worlds with a solid carbide tip and a steel shank, this tool can only run its complete performance, its maximum cutting speed and its maximum tool life on a synchro chuck, compensating the synchronization errors you may have on a rigid tapping process. Yeah, so far for our web seminar of today. Thank you for joining us here live at Schwarzenbeck. If you have any questions about our presentation of today, of course you can get all the information about our products on our webpage www.lmt-tools.com. If you want a personal contact, of course we are at your disposal. Contact us on the email address academy@lmt-group.com, and you can get all the training films, all the web seminars, e-conventions and other films we produced about our products on the video center you are already on and logged in. Yeah, so thank you once again for joining us on the web seminar. Thank you for your participation, and thank you also to my team here at the LMT Group Academy Innovation and Training Center. Thank you to Stefan Möller and Clemens Mohr, the experts leading through the presentation. Thank you to Martin Hahn, making, as always, the operational part on the machine, running the test and running the demonstration. But also a big, big thank you to the guys behind the camera. You never see them during the live seminars, but without them it would be impossible. Thank you, Darius Kowalik and Jörn Hoffmann, for IT, camera and sound. And thank you, Dr. Dieter Thomas, for being in the background, making the director and arranging everything yes, in the background. Yeah, we say goodbye from our web seminar to point out for the next events. On March 16, we have planned the next web seminar about mold and die applications, but you will get a separate information through internet and through email in the next weeks. Already now available is the expert talk presenting our highlights and our new tools of METAF 2012, and everything about this available on the Video Center as well. We would be pleased joining you afterwards in the chat room. You see once again the login data, LMT TV, and the login tapping. So, thank you once again. See you in the chat room or hear from you via email. Thank you in the name of the colleagues, and a warm bye-bye from Schwarzenbeck.